Hi, my name is Marissa Abiazi, WHS Class of 2016, and this is my solution for problem number 33 on page 163 from Chapter 6. The problem reads, Jane, looking for Tarzan, is running at top speed 5.3 meters per second and grabs a vine hanging vertically from a tall tree in the jungle. How high can she swing upward? Does the length of the vine affect your answer? So to solve this problem, we're going to be using conservation of energy. So let's begin. So, the first step in determining how we can solve this problem is understanding that she does not lose energy from the time she is running to the time she's up in the air and reaches her maximum height. Before we can begin this problem, we have to determine what we consider ground level and where energy is equal to zero. To make this problem simple, we're going to consider the ground she runs on to be zero. So, now knowing our ground level and that she does not lose any energy, we can confidently make the statement that her energy at point A, her running, is equal to her energy at point B, her max height. And so this is written as the equation U sub A is equal to U sub B. This allows us to then substitute in values for different types of energy, such as kinetic and gravitational potential. So what we're trying to solve for is this height right here. And to do so, we need to set up our statements and then plug in our different types of energy. Since she is running at point A at her top speed, we can consider this to be kinetic energy. Kinetic energy is defined as 1/2 her mass times her velocity squared. And at point B, she has gravitational potential energy, which can be defined as her mass times our gravitational constant, 9.8, times our height. So once we have written out this first statement, we can then move on with the problem. To go on from there, we then can substitute in our values. So we know that at point A, she has kinetic energy, and so her kinetic energy at point A is equal to her gravitational potential energy at point B. And once we have this written out, we can then go ahead and plug in these values. So we get 1/2 mv squared is equal to mgh. Now we're trying to solve for this variable right here. To do that, we want to get it alone. But before we even do that, we see that there's an m on this side of the equation and an m on that side. So we can cancel this out. This is beneficial since we do not know her mass since it is not given to us in the problem. So once we cancel out our mass, this is what we're left with. 1/2 velocity squared is equal to g times h. To get h alone, we simply divide by g, and we are left with v squared over 2g is equal to h. Now we know both our velocity, which is given to us by the 5.3 meters per second, and our g, which is always equal to 9.8. meters per second squared. So when we plug this in, we get 5.3 squared over 2 times 9.8 is equal to height. When we plug this in, we get height is equal to 1.433 meters. Now we have to be careful here because although this is our answer, this is not correctly This is not correctly rounded in sig fig. And so we start with 2 sig figs from the problem of 5.3, and so we must round this to 2 sig figs, which we end up getting height is equal to 1.4 meters. So we just figured out that the distance from the max height you can get from the ground is 1.4 meters. Now the second part of this question is, does the length of the vine affect your answer? So if we go back to our original statement of 1/2 mv squared equals mgh, we notice that there's no variable for the actual length of the vine. This means that no matter the height of the vine, or the length of it, that it's not going to affect Jane's ability to reach her max height. So the length of our vine does not affect our answer. So the answer to that is no.